This is CPM Calculus, Chapter 4, number 114. So we're asked to write and evaluate a Riemann sum, remember that's just using sigma, to estimate the area under the curve g of x between -4 and 0 using 20 rectangles. Then use your graphing calculator to compute the sum. Alright, so this is where we have to go. Remember, this question is asking us to find the area under g of x between -4 and 0, right? Bounded by g of x and the x-axis. And using 20 rectangles, alright? And the general form is going to be, if we need to remember, make sure you practice using this, is sigma from n, or not n, k, some variables equal to 0, stopping at n minus 1, where n is the number of rectangles. So here I'm going to write n is equal to 20. Of delta x, which is the width of each rectangle, times the function starting at a, adding delta x times k. Okay? So the width of each rectangle can be found if we know this is the region, the width is just b minus a over n, right? So n is 20. Our region is always from a to b. So this is a is -4, and b is 0. Okay? So finding the width is just b minus a over n. So that's 0 minus -4 over 20, which is +4 over 20, or 1 over 5. Alright? So let's go ahead and plug this in. I'm going to put this in a little cloud, a little bubble thing, because this is just a side note. So the area then equals sigma starting at 0, n minus 1, well n is 20, so 20 minus 1 is 19. Delta x we computed is 1/5, times our function of a, we are given a is -4, plus delta x, which is 1/5, times k, so 1/5 k. Alright. The only thing we need to do now, this again is our area using rectangles, to remember that our function is not g, so I'm going to even change it here, because it's not g, it's not f, it's g, right? Well, g of x is defined to be x times 2 to the x plus 2 power. So g of this, we're going to go ahead and substitute every x with this input, right? So let's go ahead and rewrite this. That's equal to sigma starting at 0 going to 19 of 1 over 5 times g of this input. So that means to go ahead and change x to be -4 plus 1/5 x, 1/5 k, right? I'm just copying that, times 2 to the power of x plus 2. Well, x is -4 plus 1/5 k plus 2. Right, this is x, and we're multiplying this by 1/5, okay? So there's our area as a Riemann sum, and so let's use our graphing calculator to go ahead and calculate this for us. So again, we go F3 to calculate, and now we're going to go to 4 to get the sum. Our expression is going to be 1/5 times, and then in parentheses is going to be another parentheses. I'm just copying exactly as it is here. -4 plus 1/5 k. K is above EE, right? -4 plus 1/5 k, close the parentheses, times 2 to the power of, I'm going to open a parentheses for the power here. I'm going to write it here too. To the power of -4 plus 1/5 k. Oops. Escape. What did I do? 1/5 k plus 2. Close the parentheses. Close that parentheses. Comma, my variable is k, so alpha k. Comma, my starting index is 0, my stopping is 19. So comma 0, comma 19. Close that. I'm going to push the green star to get the approximate answer and enter. I'm going to wait for the calculator to compute this, and we get approximately, it's approximately negative 6.44764. Alright, that's units squared. And that ends the problem, but I want to go ahead and let's look at how close this answer is to the actual area. Because now, remember, this is the estimated area using Riemann sums and rectangles. The actual area is just the integral, right, using the boundaries -4 to 0 of our function g of x, which is just, what is g of x? It's x times x, 2 to the power of x plus 2, x times 2 to the power of x plus 2 dx. Okay, so let's quickly calculate this. This again is not what the problem is asking, but let's see how close we were to the actual area using 20 rectangles as an approximation. So let's go to integrate, and then I'm going to put in x times 2 to the power of, in parentheses, x plus 2, comma my, with respect to x, so the variable x, x, get rid of that e to the x, comma my starting boundary is -4, my stopping is 0. I'm going to push diamond enter, so it gives me the decimal value, and the actual area is -6.36244 units squared. See, so this was what we could estimate, and this is what we can get exactly as the area under the curve. Alright, so that ends again CPM Calculus Chapter 4, number 114.